Pokemon. There's nothing quite like it. There's so much to love about this franchise. There's the characters, ranging from cute, lovable creatures like Pikachu and Jigglypuff, to powerful dragons and beasts like Charizard and Garchomp. There's the anime and the movies, where we follow the adventures of the soon-to-be Pokemon master, Ash Ketchum, and his buddies. There's the massively popular trading card game, where you can either collect valuable cards or build a strategic deck. There's a reason that Pokemon is the best-selling media franchise of all time, and it's not even close. However, one thing that you'll find in common here is the most iconic aspect of Pokemon, the battles. Pokemon battling is the defining feature of the franchise. Some of the best episodes of the anime feature awesome battles between Ash and his rivals, or between other characters. In the trading card game, there's a whole website dedicated to building a deck and battling online in real time. However, the place where the battling is the most important is within the main series games. As of now, there have been 8 generations of Pokemon games, with more coming as soon as fall 2021. But one thing that has been constant through these games is how they are structured. You play as a Pokemon trainer. You catch different types of Pokemon in order to fill the encyclopedia known as the Pokédex, and you trade them and battle them in order to defeat other trainers, until you eventually become the champion of the region. But have you ever wondered how that works? Specifically, I'm talking about battling Pokemon. The anime makes this look like they're solely based on the skills of the Pokemon trainer, as well as the bond between trainer and Pokemon. In the games, this is not the case. Instead, mathematical formulas are used for the game to determine how much damage Pokemon on the battlefield are doing with their attacks. Conveniently enough, these formulas contain algebraic concepts that can help students like you and I to be successful in our studies. So without further ado, let's dive into the math behind this madness. Here's the damage formula. This may look like an extremely complicated formula, but this mostly consists of a few calculations using values that you can compute with a calculator. But what are these values? It turns out that they can be different numbers depending on the situation, instead of one constant number. This is the concept of a variable, a letter that takes the place of a number. In math, variables such as x and y are used very often, especially in algebra and later maths. However, in this situation, the variables aren't actually always letters, but rather words, such as damage, level, power, and modifier. With this in mind, let's take a look at the meanings of these variables. In this formula, damage is the final output of the formula, which is what we are trying to calculate. Level is defined as the exact level, from 1 to 100, of the attacking Pokemon. Now, in previous generations, it was actually possible to glitch the game into leveling your Pokemon over 100, but nowadays this is no longer possible. So we will be applying this formula to the current generation of Pokemon mechanics. Moving on, power is the base power value of the move the Pokemon is using to do damage. AD stands for attack divided by defense, which are the Pokemon's attack or special attack stat, and the opponent's defense or special defense stat. I'll explain the difference in a bit. And then there's the modifier, which contains even more variables used in the calculation. Running through them quickly, targets is a multiplier used in double battles, which we won't discuss today. Weather factors in harsh sunlight or rain. Badge is a multiplier not relevant to the current generation. Critical is the multiplier from landing a critical hit. Random is a random value or roll between 0.85 and 1. Stab, or same type attack bonus, is a multiplier that factors the attacking Pokemon's type compared with the type of move it's using. Type is the type effectiveness. Burn isn't relevant unless the attacking Pokemon is burned, and other is only used in specific situations. Whew, that was a lot. But now, let's see this formula in action. Here we have a battle simulation between a level 100 Raichu, or Pikachu's evolved form, and level 100 Charizard. The battle has just begun, and both Pokemon are at full health. Raichu is faster than Charizard, so it will move first. Raichu is going to use the move Thunderbolt against this Charizard to inflict damage. But how much is it going to do? Looking at the formula, we can plug in all the variables to guess how much damage Charizard is taking. We can plug in 100 for level, since the Raichu is level 100. The move Thunderbolt currently has a base power of 90, so we will plug 90 in for power. Also, Thunderbolt is a special attack, so for A, we will use Raichu's special attack stat of 279 at level 100. As for D, Charizard's special defense will be used to counter Raichu's special attack, and this value is 269. Next, let's look at modifier. In this situation, the only multipliers that are not 1 are random, stab, and type. Let's assume the Charizard got lucky, and Raichu's random value came out to be 0.85, the minimum value possible. Raichu and the move Thunderbolt are both of the electric typing, so stab will be of the value 1.5. Finally, Charizard is a fire-flying type Pokemon, and electric type moves are super effective against flying types. Therefore, type will be the value 2. To summarize, here are all the values we will be using in this calculation. Multiplying 0.85, 1.5, and 2, we get a value of 2.55 for modifier. Back in the main equation, we will follow the order of operations, or PEMDAS, parentheses exponents multiply, divide, add, subtract, to get our final result. 2 times 100 is 200. Divided by 5 is 40, plus 2 is 42. Multiply 42 by 90 by 279, and then divide by 269 to get about 3,920.5. Divided by 50 is about 78.4, plus 2 is about 80.4. Finally, we multiply 80.4, the result of the main damage calculation, and 2.55, the result of modifier, and we get a final damage output of 205.05. In the game, this would do exactly 205 damage to Charizard, which is over half its health at level 100. It would also have a 10% chance to paralyze Charizard, which makes it vulnerable for the remainder of the battle. So what have we learned as a result of this damage calc? We have discussed the importance of variables versus constants in algebra. We found the correct values to substitute for each of these variables. We applied the concept of order of operations, which is also a key concept in algebra, and we've honed our skills using division, multiplication, and addition. With this knowledge in hand, you'll not only become a Pokemon master like Ash Ketchum, but you'll also be the best algebra student in the whole region. Thanks for watching.